And 2 months ago, I was able to do this, but I've slept through it since then, so. Done, good.
That's all right. I'm in IT. It's we get about 200 of these calls a day. So
Hey, early question. How do you pick your launch sites?
I may even mention this in the presentation, but I work it backwards. So, for instance, this particular, let's say that what you see on the screen here is a prediction of the flight. And I would say, wow, that landing target in the center of the screen there is awful close to the water. I would rather it land further to the southeast. So I would then move, I'd play with maybe launch times and see if that makes any difference. And if not, I would launch from Mount Juliet or something like that. And that would just take that entire path and move it, slew it down.
Okay, thank you.
So yeah, I work it backwards. It's really difficult when we're launching for schools because they want to launch out, at a school assembly. And what if it's going to land in a lake? There's a few things you can try to do, overfill the balloon or do some other things. But yeah, that's a challenge when you're doing a public flight, is you're launching from a maker faire or an event like that. So, all right, we getting close?
I think we are. So I think I'll go ahead and do the introduction here, and I'm just going to let you stay up here because it's already working, and that's cool. All right. So this is Paul Lowell. I want you guys to give him a good welcome here in a minute. He got started as an engineer at national labs, including the National Radio Astronomy Observatory at Green Bank, which is where one of our members was just a few weeks ago. He also got involved in early work with what is now the internet. He spent his off hours as an amateur radio and variable star astronomer. Today, Paul is a network engineer living in central North Carolina, a beautiful place. He volunteers with STEM education topics such as high power rocketry and high altitude ballooning. Tonight, he will be introducing you to high altitude ballooning. He hopes to show you that this inexpensive hobby compared to astrophotography can let you experience the upper stratosphere and simultaneously geek out with photography, meteorology, electronics, amateur radio. We got a few hams in the club too, and geocaching. So with that, Paul, take it away.
Excellent. We're getting really close to a balloon popping up over you folks right now on this live image. This is, again, we're at 96,000 feet and climbing. But let me jump over to our presentation. Let's see if we can. Hopefully you've got a picture of Bob, our big orange ball, and the edge of Earth here on your screen. This is a real image taken at 100,000 feet over my head, using about $100 worth of equipment. So yeah, those of us who, that's a filter. For those of us that have done astrophotography. So I want to talk to you about this as a potential hobby and fun little idea, and maybe get you folks thinking about maybe starting your own near space program. So yes, I'm Paul Lowell, KD4 BFP. Here's a picture of the coast of North Carolina on a clear day, sideways. You can make out the Outer Banks and what is that, the Neuse River and the Pamlico and stuff like that. So I've been doing this for about 10, 15 years. I've done over 100 flights myself personally. We do science experiments and STEM programs and so on. Here's a picture of a middle school. You usually find that 7th graders will do their weather thing in science. And so it's perfect because they have to learn the layers of the atmosphere and all that sort of stuff. So, hey, why not visit those layers? So these are different images of a flight. And yes, of course, it's vitally important when you're doing a middle school thing that you put the school mascot out on the end, or a little effigy of the principal or something like that. But we do all sorts of crazy stuff. We've sent up cameras, Geiger counters, biological samples. For instance, the person in the middle of this image here holding the balloon sent up a collection of yeast from NC State to see what the effects of cosmic radiation would have on that sort of thing, genetic research and so on. And of course, you've got the electronics and the ham radio side of it as well. And yes, we have an X-Wing up there. Fun story. This gentleman actually wanted to get some tickets for opening night of one of the Star Wars movies. So we worked with him to send an X-Wing and a Millennium Falcon up, and he filmed a little video and got some red carpet tickets. So it's pretty cool. We've set Geiger counters up, as I was saying earlier, done some, I've been playing a lot with astrophotography, which is kind of difficult from that altitude, because you're moving around and it's really hard to get good, solid, long exposure images up there, but we're working all right. My next big project is to attempt to photograph sprites and jets from thunderstorms. You're familiar with those. We've seen them, what they look like from hundreds of miles away with, looking through a telescope, but what do they look like when you're in the middle of the sprite in the jet, in the stratosphere? That ought to be interesting, and I don't think anybody's done that before. But first, before all of this, we need to kind of clear up some things, where we're going, what we're doing. Are we in space? Well, no, we're not. There really isn't a true line of space. As you're traveling up in a rocket, there's not one point where you're going, oh, wow, we're in space now. No, it's the atmosphere just gets thinner and thinner. And as many of you know, the International Space Station itself is in a rarefied environment of oxygen, which causes rust on the outside of the spacecraft. And they have to keep boosting it every now and then because of that drag. The Kármán line, the magic line, that is kind of, the line where if you go above it, you get your astronaut wings. That's 62 miles, about 100 kilometers up, right? So what we're doing here with weather balloons are only going maybe a third to a half that height. Now, are you in space? No. Would you die without a spacesuit? Yes. So we've coined the term near space to kind of add some fun to it, especially when we're dealing with kids and the various flights that we do with STEM research and such. Now, during these flights, we are above the tropopause. We're above the weather. So weather, or more likely humidity, only occurs seriously below the tropopause, down in the troposphere. That's where all the storms, the clouds, all of that lives. So we're up where you're at about 1/100th of an atmosphere, which is, interestingly enough, about surface level atmosphere on Mars. So that might get you thinking of some cool experiments there as well. And the temperature, you're going through an interesting temperature regime where in the tropopause, you're getting really cold. You're getting as you saw in that other live image, we're getting to 40, 60 below up there. Now, once during the daytime, up higher in the stratosphere, you're above all the clouds and you get some really nice solar heating. So I try to take advantage of that as much as I can, so I don't have to send heaters, heavy heaters with me on up. But as you can see by the red line here, the temperature actually starts to go back up, and it's sometimes it's 72 Fahrenheit up there, right around the time that the balloon bursts. So how do we know where the flights are going to go? How does this all work? Well, as you saw, there are about 92 different flights launched every day by the National Weather Service. We're watching them live here a moment ago. In fact, if, for instance, out of Nashville, they're launched over at the Doppler site over near what's it called? Chutes?
Yeah.
I think, yeah. So with that data, we're able to run prediction algorithms. Now, this has all been done for us. It's out on a website. So all you have to do is you plug in the weight of your balloon, the weight of your payload box, whatever that consists of, Tupperware, whatever your box is, your parachute, your cameras, whatever, the amount of gas that you're planning on putting in, the type of lifting gas, your location that you're going to launch from, and the time. And you hit go, run prediction, and it will draw out okay, here's your starting location. Here's where it predicts it's going to pop based on an ideal balloon of that type and where it would land. And as we were saying earlier, one of the things I try to do is land it in an open, in my case, tobacco field, or some open area and not the swamps, which is kind of difficult in Eastern North Carolina. But if we find that the projected path is not looking favorable for one reason or another, we can try changing the amount of gas, lifting gas, to maybe add more gas so it's a shorter flight. It'll go up quicker and come down faster, or change your launch location. So there's a little bit of fun when we're doing kind of group launches. We usually wait until the night before the flight to absolutely settle on a launch site. And we just have a list of all of our parks in the area that we can do these flights from. We try not to launch, of course, within a certain radius of an airport and that sort of thing. But again, an awful lot of these, for instance, the Greensboro, North Carolina weather balloons are launched at the international airport there in Greensboro twice a day, just as long as the FAA is aware of this. And on the bottom half of the screen here, you see a couple plots done in Google Earth. The yellow lines are the predicted flight paths, and the blue is the actual, taken from live data during the flight. So you can see they're pretty close, and you can get to within a mile or two of, or 5 of the estimated landing area. So you get a good idea. One of these for flights, I think I launched like 20 minutes late, and that's why it's deviated just a little bit, but still we're looking pretty good here. Now, as you may know, the jet stream moves up and down across the country at different times of the year. So in the summertime, you'll end up with, especially down here where you're south of the jet stream, if you're going to launch in Michigan or Maine, it may be a different story, but down in these southern latitudes, your summer flights tend to be kind of short and squiggly, where your winter ones will get sucked into that lower jet stream. And when I mean lower, I mean latitude-wise, and get hauled out to sea. And of course, your predictions are based on those National Weather Service flights. So the closer you can run your prediction to the actual flight, the better your prediction is going to look. Trying to guess a week out when you've got crazy weather patterns that we've all been dealing with over the past 6 months moving across the US, it's kind of fun. But general rule of thumb is if you want the payload to travel faster, then you can drive on an interstate than launch in the wintertime. So it's often a summer hobby. We spend the winter either doing these really long runs, or we do some other flights, which I'll get into later, which happen to involve going around the planet. So does anyone here know where we discovered helium? Anyone want to speak up? Any ideas where the name helium comes from?
Helios means the sun.
Exactly. So astronomers using spectrographs, but he's looking for this element number 2, and they find it on the sun. They figured it only existed on the sun until folks started wondering what this weird stuff was that was bubbling up out of the natural gas and the oil, crude oil, that we were hauling out of the earth. Come to find out that the helium on the earth is actually alpha decay particle from radioactive decay underground. Uranium and things like that naturally decaying underground. So we, as a country, collected a lot of it. We were holding on to it to keep it away from the Germans because they were using it for Zeppelins, during the wars. And in 2007, the US got rid of their strategic national reserve of helium. So when you think about it, helium itself is a limited natural resource, and it's really limited, comes from radioactive decay. We can't really make it. I've been working at Lawrence Livermore, working with nuclear fusion, and we always say, fusion is 20 years away, always 20 years away. So right now, it's very difficult for us to make helium. So we tend to not use helium. We use hydrogen instead. So this image is, around kids, and we tend to use, we originally used helium around kids because the school administrations had problems with, potential Hindenburg incident in front of lots of school kids. We've come up with ways to get around that, and ways to safely use hydrogen. Not only that, when we're working with like middle school students and so on, we even have them make hydrogen and oxygen in the classroom by splitting water, and that's a fun little easy experiment that the teachers will do, and it kind of gives them an idea just how renewable hydrogen itself is. So that's one thing we want to mention. Also, helium costs about $200 a flight, and hydrogen might be about $15 a flight. So the real reason is it's a very affordable lifting gas, and hydrogen is very renewable as well. So we have all sorts of live telemetry, as you saw on the live map earlier. So for instance, there's an image in the lower right here. You can probably guess when that image was taken, because if you see the line running from Oregon down to South Carolina through the center of the US, and think about what's happening next April, this was our national attempt to collect data during the eclipse. So that was a lot of balloons we sent up that day. That was a blast. But we do get live telemetry back as an option on these balloon flights. And sometimes, for instance, with the students, we'll run a mission control. Some of the kids may have parents, the typical soccer mobile or whatever, and we'll haul folks out to do the chase and the recovery, while the others run mission control. And we have them watching the live telemetry, and, you have Capcom and PAO, all of these different groups set up, and it's a lot of fun. So here's some other examples of some things. There's the Millennium Falcon. Launching during a hurricane, that's a blast. I usually try to find a parking deck and do the fill and prep down in the lower level of parking deck, and then run it up the ramp and quickly release it at the roof of the parking deck as we're launching up into hurricanes. But we've done some really interesting stuff over the years. And we can't, of course, forget Space Ducky here. And yes, if you're sending a rubber duck to the edge of space, it needs a helmet. That's important, because otherwise people will get concerned. But notice the thunderheads in the background. That's pretty neat. And of course, up that high, since you don't have Raleigh scattering in the atmosphere, you've got black sky. And it's beautiful. It's really beautiful up there. This is about 90,000 feet on a partly cloudy day. So you see the little cotton balls. It's always interesting seeing how kind of drab the Earth is. And this is looking towards the Appalachians, and you really can't make them out. There's just nothing, no contrast, and no height. It'd be obviously different if you were out west. And here is, it's at the Pamlico and the Pungo rivers at 122,000 feet, looking off the coast with all of the clouds out off the Gulf Stream there. So some of the other things we've done, this is what the SpaceX Inspiration 4 upper stage looked like as it was coming up the coast. That, if you recall, that was just after sunset, that launch. We've been able to film these types of launches, and we can make out the first stage separation, first stage entry burn, and landing burn, where it lands on the barge off the coast of North America. And of course, the spacecraft as it goes booking on by. And we've got Jupiter here, and looks, I think, up in the middle of the sky there is probably Antares. Yeah, that was facing that kind of southeast. So that would be about right for that time of year. And for your J.J. Abrams fans, there's always fun with the lens flare. So it is kind of a poor man's astrophotography up there. You are in a kind of a moving, swaying payload. So trying to do any long exposures without a massive NASA stabilized environment can be a little difficult, but some of this stuff is not impossible to do. I've got a few messier objects captured. It took I usually, like you do with astrophotography these days, you video it and then try to pick and choose and stack images. But you can do some really interesting stuff up there. Another thing is, those of you who've ever sacrificed a webcam to put on your telescopes and remove the IR filter, well, what happens when you send one of those up? And I think it's fascinating here how the lakes just kind of pop out. So it's real difficult to see with this kind of muddied out ground image. And of course, you're looking through a lot of haze too, but to see that all of the rivers and the streams really pop. And you can also tell the difference in types of trees, the deciduous versus whatever. You can tell that with the IR filter removed. So there's a lot of interesting stuff there. Trying to think of some other fun things. This was a wonderful little styrofoam glider that I got at Walmart for $9. It's one of those that you slide together. It's about 4-foot wingspan. You throw it 3 or 4 times and it breaks or gets stuck in a tree. Well, if you take a $50 balloon and $15 worth of hydrogen on a 30-foot string there and send it up, you can have the highest recorded toy glider, the longest glide of a toy glider, the fastest toy glider in history at 488 miles per hour during re-entry, and a wonderful 5 hours time to spend a Saturday. So, and of course, I've got 2 cameras on board here, and the antenna is the tracking antenna. So I've got 10 hours worth of video of this thing going up and then popping and then coming down and gliding across up I-95 as we drove underneath it, trying to stay in track with it. Now, I talked about popping. This is about a 30-foot piece of string in front of this little toy glider. So, and you might notice that at the beginning we showed us holding a big latex balloon. It was about 5 feet diameter, 6 feet diameter or so. By the time you reach the middle stratosphere here, those latex balloons have grown. Again, we've sealed it off. We've taken zip ties and zip tied the thing off tight, and so gas isn't going to leak out, and it is expanded to 35 to 40 feet in diameter. And it gets to the point where you can see through it, and eventually that thing is going to fail. So these are 3 frames from a video. So they're 30th of a second apart from each other. And this shows the latex weather balloons failing, what it looks like. And we've got plenty of video like this out on YouTube if you're interested in looking at this sort of thing. And what I find really fascinating with it is they pack it with a kind of a talcum. Well, I imagine it's really like a cornstarch or something when they package these things. So it leaves this wonderful ghost image of the balloon behind as it pops. But it also shreds really well. And I think that's by design. The companies that make these for National Weather Service want it to shred. And this is natural latex, which we've done some experiments and we found that the critters in North Carolina at least love it. Worms and bugs and stuff love natural latex. So this stuff is completely natural and it biodegrades pretty darn quickly, especially when it's shredded in tiny little pieces. And I'm sure the Weather Service knows about that because they launch, again, 92 of these things a day. So you can imagine there's a lot of latex pieces all over all of our areas. But yeah, it pops at that point. Now, the burst itself can be a little violent. Your payload typically spins around The concussion isn't that much because, again, you don't have that much atmosphere, but you can see the little shreds of latex as it's blowing everywhere. The payload would turn sideways. That's where you get a lot of these sideways images of like the North Carolina Outer Banks and so on, is because of that tumbling. But then the payload starts to fall. Now, when we design our payloads, we could come up with all sorts of cool actuators and engineering for making this thing work. But honestly, the easiest is to come up with something with no real moving parts. So that is a balloon, piece of string, a parachute, more string, and then your payload box. So again, balloon, some string, and a parachute, and then whatever your payload or whatever you want to call it consists of. And the idea there is when the balloon pops, it's going to blow into all of these shreds, and then the thing is going to come down. There's no, unlike model rocketry, there's no deploying the parachute because it's already there. It's just been hanging there unused up until its point. Now, the fun thing is at 100,000 feet, a parachute doesn't really do anything. There's no air. You're at 1/100th of an atmosphere. The parachute might look like it's open, but you're coming in at 100, 200 miles per hour. You're booking it inbound. Even that glider came in at incredible speeds. So it's not until about 50,000 feet that you're even noticing a slowdown. And 30,000 feet, you're coming in about, let's see, I love mixing units here. I'm thinking 20 meters per second at 30,000 feet. Anyway, it's really not until you're about around maybe 10,000 feet that the parachute is really biting in and doing what you expected it to do. And then during all of this, of course, you've got live telemetry coming in. You're watching on your magic map. Your little icon has changed from a balloon picture to a parachute picture. Your students or your chase crew, your buddies, all your fellow ham radio folks and so on are out in the chase cars. And of course, the chase cars show up on the map because it's cool. So why not? And we're now entering what I think of as kind of a storm chasing mode. So you've got something that's coming in. You've got a approximation of where the payload is going to land, but you're out on country roads. And it's zigzagging, and you find that you zigged when you should have zagged, and you always come to a T intersection. Should I go left? Should I go right? And it's always the wrong one, or so on. We get lucky sometimes. So I've got an image here of one of our few flights where you can actually see the chase car with us standing outside with binoculars looking for it, as seen from the payload. But those of you who've done anything with model rocketry, let me ask this question. You've got a big, beautiful open field with one tree in it. Where's that rocket going to land? So in the center of the image here, you see the projected landing area, the red line, and then you see reality where it goes, no, that's a beautiful open lawn, nice lawn of a fancy house there. I'm not going to land there. I'm going to stall out at 200 feet above this forest and land in the middle of the forest. So this is where your hobby now has gone from storm chasing to geocaching, right? You've got a latitude and longitude fix of this payload, and now you've got to go find it. Honestly, this is one of the things that we find very useful when doing student launches, is having the students there to recover. It's amazing when you show up at a house in the middle of the country with little kids saying, yeah, I need to get my science project, and no problems. They're willing to help. The shotguns go away, otherwise you get some dorky looking guy with a near space shirt on who's knocking at the door. No, it gets a bit sketchy. I always try to bring a good old boy with me, so he can speak their language and all of that when we're doing recovery. Sometimes these things will land in trees. I've got a friend who is amazing with a bow and arrow. He's got an arrow with a golf ball that's on the end, and he lobs a fishing line up over the thing and can pull it down really quick. Sometimes we're lucky and it'll land in a field. It's kind of difficult when it lands in really tall vegetation, like you would see in the Midwest. That's where they often, a lot of the folks in Kansas that fly these, for instance, we have an event where everybody meets up and does National Launch Day in Kansas or something like that. And they often put little beepers or buzzers on their payloads, so you know under which corn stalk this thing is landed. But I'm looking at one sad case down in the very lower right. Yeah, that's the one tree in the middle of the woods, and that's middle of the field, and that's exactly where that landed. So again, is kind of a review on this whole thing. We're talking about a mix of hobbies. It's something that's relatively easy to do. We know it's allowed. There's rules for the FAA on weight, density, how the tension on line on the string before it can break. They're worried about it smashing jet windshields. So as long as it's low density, all of these things allow it to be in a category where it's called exempt, and exempt flights can happen. And honestly, I call in to the airports and get a NOTAM to launch. I've been noticing over the past 5 years, I'll call in and they'll say, this is an exempt flight, right? Yes. So why are you calling us? You know, why am I having to fill out this paperwork? So I'm getting the feeling, you know, yeah, we're filing a NOTAM, which is a simple process for some of these flights, but I know plenty of people who don't bother because they're just finding that if there's 92 of these launching a day, it's just the pilots are going, yeah, there goes another weather balloon. And honestly, you're only in the flight path for about 20 minutes out of a 2-hour, 3-hour flight. So let's see, what are some other items here? We use hydrogen. The lighter the payload, the higher you could achieve. Now let's work through this. You've got a balloon that's stretching, and when it gets to a certain size, it will fail. So if you have less gas in that balloon to start with, you have more time of it stretching, right? Well, with less gas, that's less lift. So you need to make your payload lighter. So again, if you end up with a really lightweight payload, you can fill the balloon with just enough gas to lift it at a meter per second, 3-4 meters per second. And you can get some amazing heights. My record is 142,000 feet change. I think that's like 7th in the world or something like that. The typical one of these flights, just like you see with the live weather service stuff, is about 2 to 3 hours. So imagine maybe 2 hours up and 30 minutes coming down, because it is going to haul when it gets down, at least until it gets down below 30,000 feet. The flights are all at the mercy of the jet stream, but we know they're characterized by all these National Weather Service flights. And honestly, let me show you. It's a reasonably inexpensive flight. So you've got a couple things that you have to pay for each time you fly. One's a balloon. It's a big old, what is it? It's a 6-foot condom. It is a big old piece of natural latex, about $50. And yeah, there's shipping and handling. So if you are going to do several of them, you can save there. Hydrogen gas, a $32 fill of a tank can get 2 flights out of it. And then there's tank rentals. We find oftentimes with schools, there is somebody who works at a welding supply company or something, and they donate it for the school, and that's wonderful stuff. You've got the filling attachments to go from the tank into the balloon, some kind of PVC pipe and hose and that sort of thing. Those are one-time costs. You've got your payload box. Well, I don't know if you guys can see this. This is a container that dish detergent came in. And I cut it all up and put payloads, electronics in it. Now, some of the images earlier, I want to talk about this a little bit because it is something having to do with how you design these things. Lots of folks will take a big styrofoam cooler because, hey, it's going to be 40 below up there. It's going to be cold. I don't want my batteries to freeze, right? It's like doing astrophotography in the wintertime or so on. You want to keep your stuff warm. Well, what I find is, and well, let me go through this whole thing. You've got a box. Let's say it's a big styrofoam cooler. You've got your electronics around the inside, maybe some dead air space inside that styrofoam box. So, squeaky white styrofoam box, and you send it up. You're at room temperature inside at normal atmosphere. Well, as it goes up, the atmosphere will leak out of your payload box, and it will get colder and colder on the outside. Well, and of course, your components inside, hopefully they will stay warm and your batteries will stay good and so on. Well, then after burst, it's coming back down. Well, as it's coming down, the atmospheric pressure is now increasing 100-fold. And where is it increasing? It's increasing in that upper troposphere where it's 40 below. So you now have an inrush of super chilled air coming into all of that open space inside your styrofoam box. So I've seen flights where folks will open up their styrofoam box and find frost on all their equipment inside. So instead, I do a couple things. One is I use clear box that has black foam on the inside. It's like the stuff you can see this a lot with lens cases and electronics cases. And I can cut it all out to hold all my equipment inside. So I try to reduce the amount of dead air space inside. And I also have now made a terrarium, black stuff on the inside of a clear box. So that solar heating, that intensely strong sun up at 100,000 feet, beams into this and warms this up, and it's nice and toasty inside. So it can survive better, and your LiPo batteries and so on can survive the coldness of re-entry, of coming back down through the tropopause. So one other thing that I've seen with this that I never would have thought of, we had and here on the graphs, you can see there's temperature versus altitude graphs, and the inside and outside temperatures, and scary things like seeing your battery voltage drop as the temperatures get low. So for instance, on some of these graphs here, you can see that as you go up in altitude, temperature is dropping a little bit, but then as you're coming back down, the temperature really drops because of that inrushing cold air, and your battery voltage starts to really plummet. But another thing we've run into, and I don't know if hams have ever run into this, is your little antennas. They're little ham radio 2 meter or whatever antennas. I had a set of antennas that were actually made out of some kind of pulled steel. I guess that's how they make it. They pull it, and it makes these really nice little whip antennas. Well, at 40 below zero, these things decided to go back, it's like memory metal or something. They decided to go back into their original shape, which was in a little spool. The antenna would lose its libido. No, it would flop or coil up as it got really cold. Now, as it got up to 100,000, 120,000 feet, the antenna would straighten back up again. But I found it was really interesting because I was losing reception around 40,000 feet. And I was wondering, why would it go away and come back? Until I put a camera on the top deck of a payload and actually filmed the thing. And you can see some stills there in the lower right, where you can see the antenna actually drooping from that temperature because, again, these interesting cold temperatures. So how do you keep your batteries warm in a situation like that? I tend to use this terrarium method, but it's not very useful during night flights. Some other things to keep in mind, and this gets more onto the geek side of things. A lot of these tracker units, and I'll get into that here in a minute, use little GPS antennas. Well, the cameras we use give off a lot of interference, radio frequency interference. And we find that if we put a camera really close to your GPS little patch antenna, it could actually scream over the top of the received GPS information, and it no longer knows where the thing is located. So it's like using a GPS inside a house or something. I find that just simple aluminum foil or that wonderful copper tape that you see on NASA stuff. that helps out a lot. But honestly, inverse square law helps a lot too. Just move the camera further away from your GPS stuff. If you want to, you can have multiple little boxes on your string hanging under the balloon. It doesn't all have to be in one piece of Tupperware or something. So, so radio interference can be a problem. Violent shaking. Make sure you put an extra wrap of duct tape on your payload before you launch it, because you don't want the contents to open up at 100,000 feet and spill out all over the countryside. You're at 1/100th of an atmosphere. Are you sending up a payload with like test tubes with a stopper on it? They'll probably pop. Putting things in a Ziploc bag, yeah, they'll probably open or pop on the way up. Then there's also radiation. And this is a fun one. And if you knew about Pfotzer maximum, you probably wouldn't want to fly in jets ever again. But cosmic rays are, of course, coming in all the time. Some from the sun, some from, GRPs, all sorts of sources. Some intergalactic, some extrasolar. Those high energy particles are kind of few and far between. But when they get to Earth and get into the lower atmosphere, we're talking about the altitude 30, 40,000 feet of where jets fly. They hit atmospheric molecules and they shatter them. And then those pieces shatter as well. So you end up with this kind of radioactive storm that's really interesting. Now, down here at the bottom, I've got a graph of, microsieverts per hour during a flight. And I have a blue line showing the altitude where the balloon is going up and then it pops and comes down. And you notice there's this radiation level about halfway through the flight that's pretty high. And of course, you go through that twice, right? The cold region on your flight, you go through twice. Well, this high radiation area, you go through twice as well. Now, honestly, I've never had any kind of problems with onboard computers and high energy particles, flipping bits and that sort of thing. But it is something interesting to experiment with. One of the gentlemen at Green Bank suggested taking a CCD camera and flying it on one of these flights, but cover up the lens and see if I've flown Geiger counters before. Those are easy, but what happens if you fly a CCD? And it doesn't have to be an expensive CCD like you'd use in astrophotography, or just maybe one of those big ones, like a 1-inch square CCD or so on. This thing is about a centimeter square CCD inside this little toy. And what would happen with it covered up with these energetic particles hitting the CCD and setting it off? So you're taking a video of black, but then, as a matter of fact, he even wrote code that would look through the video for individual frames that had hot bits, hot pixels in it that were generated by cosmic rays. So if you took several cameras and kind of stacked them, especially these $12 cameras, little keychain garbage cameras, some of these pictures that you saw here made with a $12 video camera, keychain video camera. You stack a bunch of these, you now get a three-dimensional representation of your cosmic rays coming in from outer space. Now, can you correlate that to a source? I don't know, but it's interesting because that you can figure out, roughly where it's coming from. Was it coming through the Earth up through? No, it was probably coming down from above, and a lot of them coming from the sun. So you do a launch at noon with cameras that, strangely enough, are taped over. You put electrical tape, put them in a dark box, and have them record this stuff. So that may be an interesting thing to try out in one of these coming flights. So now, as far as these trackers, this is the part where we try to get the ham radio operators to kind of sit up and listen in on this. There's a lot of different ways we can track these things. We're taking GPS information and we're spitting out, in theory, you could send the thing up without a tracker, or you could try to use some kind of cellular based thing. Honestly, cell does not work unless it's on the ground. So you might get if you have a cell tracker, it might work once it's landed back on the ground again, but you won't have any idea how high the thing went or how close it is to the predicted track. So you won't know where to really go until maybe it's too late. any of you hams ever heard of APRS? That is there's a common website where you can go out.
Automatic position recording system.
Yep. Excellent. And that's typically used on 2-meter, 144.390. You can get little ham radio tracker units. The ones I use are actually, I've got a set that come out of China for $100. So, but it's APRS. It shows up on a public website, so everybody can see it and track it. And it shows up as a little balloon, and you can have it send down a little greeting along with latitude, longitude, and altitude. Using Raspberry Pis or little microcontrollers, you can put together something for maybe $50 that will actually do your transmissions. I have been working for the past 6-7 years on a different broadcast technology called LoRa. It's a long range packet transmission. The chips for transmitting LoRa are a whopping $5 a piece. So you put that alongside a $5 Raspberry Pi with some free software and a camera, and my fancy 433 megahertz 70 centimeter antenna, and you now have a system that's with a little plastic case and a battery. Okay, let's call it $25-$30. Will transmit live still images from the edge of space to an area maybe 50-mile radius below, all using a 10 milliwatts of power. So the designs, the plans, the software, all of that is available online. I started playing with a particular model of a device that I got from China that is one little box, one little board. It even has the battery holder on the back. Can't get any easier than that. So all the software is all available. It's a GPS built in. This thing is $24 from AliExpress. Okay, I've added a $1 temperature sensor on it that can hang outside and give me outside temperatures. But this little thing requires one up in the payload and then one down in your car. And yet this little chip will do Wi-Fi too. So if you've got your cell phone set as a Wi-Fi hotspot, this thing will even transmit out to that website that we were just looking at. And your balloon can be tracked live with something as simple as that. So it used to be pretty tedious with big ham radio gear on board. Now we're talking something that is about 40 grams with ready to go for $25 and an afternoon of loading software onto a microcontroller. So pretty cool stuff. There is also a ham radio technology called Whisper that we're using kind of in a strange way, but that's for the around the world flights. And I'll get into that in a little bit. So you end up with these, again, yet another type of hobby that's pulled into this. You've got these various electronic things. So if you've got a ham radio buddy with a call sign, you're ready to go. You can track your balloons, but they also make these $26, $25 boards that use the 915 megahertz spectrum, which is unlicensed. So now we have school teachers with no ham radio licenses that are able to launch and find and track their payloads because they're using those free and open frequencies like the 2.4 gigahertz and 5 gigahertz frequencies that you have for Wi-Fi. So pretty cool stuff and pretty achievable. We've even got folks at a local university or student teachers that will get these things and program them up and add all the experiments the kids want onto them. And there you go. You've got your trackers. So interesting stuff. And it all shows up again on these maps that we've already got running and building. You could also buy, there are other hobbyists that have kind of made a side business selling these trackers. So it depends what you want. Some of these were originally for model rocket tracking. But they all work really well for high altitude balloon flights too. This whole Raspberry Pi thing I think is really interesting because it also is one extra fun thing to it. You know, you've got your camera, it's sending with slow scan transmissions, live images from the edge of space. And also it's recording how it was going up. Every 100 feet, the software, which again, Dave Ackerman wrote here, it records what it was doing on the way up. So at burst, it takes that data, works it all backwards with an algorithm, takes live performance of the parachute, how well it's working, and while it's transmitting pictures and transmitting latitude and longitude, it also transmits its belief of where it's going to land. Which is really cool. I mean, you talk about AI and stuff. It's really cool to have a little balloon with, a little payload that is actually telling you, I think I'm going to land here. Now we don't want to get in trouble with the FAA or anything by making something that could change its landing location, but I guess it would be possible to maybe reef a parachute. If you find you're going to land in a swamp, tell the parachute that you don't want it to be as efficient as it is. Maybe have stepper motors let out, luff the parachute or something, so it falls faster and lands in an open field. I don't know. There's all sorts of interesting stuff you can do with that. And again, all of us that are in the hobby have done things. We've got Dave has got a watch that he can walk through the woods and it will receive the signals live from the transmitters and show on his watch how many feet away it is, turn left at the stump and, it's up in the tree, that sort of thing. But again, we've got these things that are using either ham radio frequencies or the public ISM bands for transmission. And there's all sorts of amazing stuff that you could do with this, not only just trying to recover your payload, but also sending back live telemetry. I've done two-way telemetry. One of the interesting things here, this image in the background was made by taking all of the APRS data on a flight. So the red dots are where the payload was, and the little green lines point to people who received the signal. So we have folks in central Ohio that have picked up the radio transmission from me over Raleigh, North Carolina. It's direct line of sight stuff. So I have also turned that around and have built a unit that receives APRS signals from 100,000 feet up. And I was able to track a private airplane flying around Miami from 100,000 feet up over Raleigh, because I can see it because your radio horizon is set up that way. So let me mention one more thing here, and we'll do some Q&A. There is another segment of the hobby. I'm kind of laying low on it right now. It has to do with taking little Mylar balloons and going around the planet. Those party balloons, the Mylar balloons that last forever, the happy birthday silver things that just, they're always up, Well, you take one of those and you put the smallest circuitry you could possibly make with a little solar panel on it. These circuits are about the size of a postage stamp or two with a little thin film solar panel, and you release those things. So a buddy of mine went over China 8 times with it back in 2016, 2017. So the fact that we've got the Chinese returning the favor, it's sorry. We started it. But again, all this thing is doing is it's sending out its latitude, longitude, and temperature. There's no room on something that weighs 7 grams. There's no room to put in a camera and stuff like that. But there's an image of one that I launched right before. And matter of fact, one of our friends got his shot down over the Yukon by the U.S. Air Force, because it was an unmarked. If they would have asked, we would have said, yeah, that's Bob's. We have the live tracking of these things, so we could tell you where it is. So we've been talking with senators, and they kind of understand where this hobby is. But I just want to let you know that this is a hobby as well. It's more interesting of how can you design incredibly lightweight electronics that can survive swinging on a balloon going around the planet. And again, those Mylar balloons, they go up, they can't really expand, they don't stretch. So they go up to about 40,000 feet and kind of hover and just go around the planet a few times. Then they'll come down in a storm in the ocean, and then a sea turtle will eat it and die. You know, it's that kind of problem. So, but needless to say, this hobby is a pretty straightforward hobby. And I ran long, but if you've got any questions, I'd love to take some.
That was fun. I want to be younger, so I have more time to do this stuff.
Oh, is it going to land in the water?
Ooh.
So it's coming down on parachute, and
It's a nice night here. There'll be some bass fishers out.
Is this in real time?
this is real time. It's at 12,000 feet and falling. It's falling at a rate of 1,150 feet per minute. No, wait. No, that's vertical. It's moving sideways at 352 feet per minute. Again, this is the one that was launched at, it would be what, midnight Zulu. So what's that, 7 p.m.?
Well,
6?
haven't it now. But
Yeah, I never, DST versus, CST versus CDT always throws me. But yeah, it's on its way down, and give it a moment. It says it's so low, it's going to land. Oh, neat. It's going to do a curly Q and land in this neighborhood here. So you can find these things out in the woods. They're just little cardboard boxes. Oftentimes you peel off the thing and fold it up and drop it in the mail, and it will go get recycled back to the Weather Service. It has kind of a chemical battery on it. Some of them used to have a thing where you kind of like pull a ripcord and the battery chemically starts up and it starts transmitting and that sort of thing. So, and again, how many of these? 92 a day. So all over the place.
Do you ever have payloads where you put 2 balloons, one with just a little bit of gas and one with a lot, so that the one that goes up higher, faster, but then the big one blows up, but the other one still remains?
Absolutely. That was one of the things I wanted to do is, how can you boost it, give it an acceleration and then slow down and do stuff. Come to find out, what I wasn't thinking about was the fact that the 2 balloons fight each other. So what I ended up really was a balloon that did most of the lift, and then another balloon, which again, acts like a sea anchor, right? It's a big round thing, and it's being dragged against its will up. And the payload is caught in between, being thrown all over the place. So some of the worst video I've ever taken, because the poor thing was just ripping back and forth as the 2 balloons were fighting each other, because it was like dragging a balloon, like running, holding a balloon. It's just kind of doing that. And it ended up breaking the string finally, so I could, and thankfully I got some video back. But yeah, that was, I wanted to do that, have that extra burst and then have it pop and then kind of slow down and then do some cool stuff with it. I was hoping for some wonderful stuff, but I forgot about the fact that it's actually an aerodynamic drag, and one balloon, trying to get the 2 to exactly the same lift. Yeah, it's not going to happen. You're always going to have one pulling the other one against its will up. So, but yeah.
You can't put the smaller balloon inside the bigger one?
I tried. I was trying to figure that out as well. And then the wife was like, this is flammable hydrogen, right? And you're going to be fiddling with this for 2 hours in the backyard with static electricity. And I'm like, well, there's no oxygen in the balloon, right? It's 99.9% hydrogen. There should be no problems. It's not going to detonate because there's no oxygen inside the balloons. And then, yeah, how do you fill? Which one do you fill first? And then,
Hey, hon, watch this.
Yeah, that's because that's exactly what these are the kind of questions that you come up with as you start. What haven't we tried yet? And yeah, I've done a lot. If you go to ncnearspace.org, and I've got a new version of the site out too, you can see some of those because we do write-ups of all of our flights. So you can see images of what flight number 14 or whatever looked like when it was dragging the other balloon behind, and the video and it breaking free. And, I have all of those write-ups of each of those flights on there, including all sorts of pictures, YouTube videos, other things like that. Hey, it's at 7,200 feet. Its maximum height was 109,000 feet. Pretty cool. Too bad these things don't have cameras on.
Paul, I think it's pretty amazing actually how relatively close to the launch point that it ends up landing after all the gyrations it went through.
Right. And again, it's that summer weather, right? So if this launching in the wintertime could land in Raleigh, North Carolina, it will go at 70 or 80 miles per hour due east in those jet stream halls. Or, well, with the way it curves, it may be like landing in DC, but it's or Atlanta. But yeah, this is, I love summertime. I've landed just under 2 miles from a launch site once. It was pretty cool. And also in the summertime, it's fun to launch from your house and then lay on your driveway. And it's like, it's like watching the Perseids in the daytime, only you're just watching the balloon at 100,000 feet with binoculars. And then you see it suddenly it disappears. And you're like, what? Oh, it popped, and then you look down at your website and it's, oh yeah, it's falling now. But yes, wintertime flights, yeah, you better have somebody downstream to catch because you're never going to catch up with it driving on an interstate.
I noticed
Thank you.
the velocity looks like it's increasing as it's coming down.
Yep. And again, that's that data that they use to make what the winds are doing at each height. And, if they find the winds are spiraling up on their, what do they call it, a hodograph or whatever, that's how they can figure out if it could be tornadoes because of the winds changing direction at each altitude. And so all of this data is all being recorded by the Weather Service to create all of their maps. And over here, you can see received 10 seconds ago, 12, 13. And of course, every time it receives a packet, this will update, drop back to 0 again. So it's interesting stuff. Let's see, there's all sorts of other buttons you can hit on this website. Let's see what the plot does. Well, hey, cool. Bunch of data, graphs and stuff. Who doesn't love that? All right.
All right, any other questions?
Give us a call sign again.
Kilo Delta 4 Baker Papa Baker Foxtrot Papa KD4 BFP.
House and the dogs.
Yeah, 4 KFT.
Yeah, we picked up a Maltese, but that's the one I drove up to Virginia to pick up. It was one of my wife's niece's dogs. They were moving and I had to get rid of the dog, and so I went.
Tony, mute your mic.
That's dedication, buddy. That is dedication. And money. You figure I dropped $300.
I was talking to his hand. Tony, mute your mic. There we go. I think that got it.
So yeah, this is, some of this stuff is astronomy adjacent. What I find interesting are these low light cameras. They're used for drones for flying at night. And okay, low light color camera for $70. So little experimenting with the scope, maybe 3D print up something, and I get some pretty reasonable results out of these. It's interesting going between hobbies, using one of these little drone cameras for astrophotography. Yeah, it's not a wonderful CCD, but yeah, yeah, it works, and you get some pretty interesting stuff out of it. And it's so lightweight, I can take this, like go to a national park with a scope and set up and not have all your rig and your laptop, all your gear. All you have to do is push a button, turn it on, and, make sure your focuser is set right, and you can do some interesting stuff with it. 1,000 feet. It's going to be landing really soon. Anybody know anybody up here? Where is this, Hendersonville?
The Boy Scout camp close there.
Yeah.
I know the ranger.
Oh, I don't know what the altitude is there, but I think we have touchdown next to the Hendersonville Arboretum.
Aw.
So let's see.
There's a lot of traffic lights between here and there. Put it that way.
Well, there's a tree, so we know where it landed. But it's still sending data, but its altitude is staying at 675 feet. So that must be
That's
the ground
about-
level.
Yeah.
And notice the system, the website knows to get rid of the parachute, and it just shows it as the payload. So they just had a piece of the Weather Service land in their backyard back here. There's probably some dogs yapping at it right now. But yeah, interesting stuff. Let's see how many are left up in the US. Most of them are on their way down or have landed already. And again, this is called sondhub.org. I don't know if you can see the URL here. There is a separate page to this, which has all your tools for doing your high altitude tracking and flights. And you can see all the stuff that we've flown around the world. And for instance, there's even this little car thing. You can put in your whatever you want to call your car and turn it on. And if this is on a mobile, let's say this is running on your phone, it will now put your car on the map. And that's how we do the car tracking part. But yeah, this is National Weather Service data. And we have plenty of others. You can turn on if you, right now I've got Freedom units turned on, but we can go back to metric. So you can see all of this stuff across the US. And of course, the weather services around the world have kind of clued in on these times. So you can see that all of the European weather balloons as well.
Wow. All right, that'll be another perpetual tab open on Firefox. All right. Any other questions?
What was your website again?
The website is ncnearspace.org.
North
So-
Carolina, near space.
Yeah.
Yeah.
Not space, but you die without a spacesuit. So we're going to call it near space. www.ncnearspace.org. I think I've got 92 of the flights up there. Our last flight, the people you meet during recovery is amazing. Our last big public flight, we did some science experiments. It landed in a pond, a lake used by a water skiing camp, which is run by a family who have like all the world records for fancy water skiing. And it landed in the water, and it had a styrofoam outrigger. So it landed and stayed floating. And we have video, beautiful video of it splashing and the people coming out to it and picking it up and bringing it back. And the getting together with these folks that run the camp, meeting up with them and explaining what this silly hobby is. And of course, they're like, hey, this is something that we can talk about. And, hey, can you get us on the television? Free advertising, there's all of that fun stuff that happens. The farmers are fun. I've had one caught in a tree and a farmer said, oh, I can fix that. I got a parachute that I've kept because it has birdshot in it, birdshot holes. He nailed the parachute beautifully, blew it out of the tree. Payload was perfectly intact, not a scratch to it. and I've got video of the whole thing, and it's just epic because this guy's like, I can fix that. Yeah, it's just a lot of fun.
Question.
Yeah.
Your video, is that live to the ground or do you have to recover a memory card?
When I'm doing my normal videos, I put it on the card because we're dealing with such high bandwidth. The only real way to do video would be something similar to what we're using here, and you would need a point-to-point microwave link, and we're talking some pretty sizable power requirements. So majority of these will have a little SD card on them, and then that means you have to get the thing back, right? You got to have a tracker and get it back. Now, we have had a few that lost their tracker from one reason or another and eventually got it back. We put a contact sign on it that says, this is not a bomb. It's a box and it's blinking, but don't worry. Here's how to reach us. This is harmless. And that helps, but yeah, we get the video back that way. The only thing that I've really been able to consistently get back data wise for images would be stills. And those come in chunks, like it builds. It's kind of like watching, I don't know if any of you guys have ever pulled down data from a weather satellite, as a hobbyist, but it comes through in little pieces and kind of builds the image.
We call it WeFax, yeah.
Yeah,
And,
exactly.
Or you could bring it down as slow scan TV.
Yes, when we did a launch slow scan TV as well. But this software that runs on the Raspberry Pi, the free software that does the JPEG from a Raspberry Pi camera, it's all written, ready to go, and it's beautiful. There's a matter of fact on this SondHub website, there's a place where those images come down, so you can see people in their labs testing out their payloads, and then on launch day you get to see them across the world sending beautiful pictures in. So it's pretty cool. And there's all sorts of things that, directions people can go in. We've got a local brewery that sent some yeast up and then made space beer, there's always something strange. We had an arcade bar send a little mini arcade thing, little Space Invaders thing to the edge of space and filmed it. And, the stuff that the middle schoolers come up with is always fascinating. And they love sending their mascots up as well.
What's the longest distance you traveled?
Well, does going around the world 8 times count? That's a different type of the hobby, but I've done that. I've launched from Asheville, North Carolina, up in the mountains, and had it land about 1.5 miles from the ocean. That was a nail biter. So that's across the entire, that's kind of like the width of Tennessee. It's that same kind of, general distance. So during the eclipse, I launched from, what's the name of that town? It was along the Totality Path north of Chattanooga. There's a river and a nuclear reactor over there in that area.
Clinch River?
Yeah. So I launched from there, and we did a recovery in North Carolina, but that was kind of reasonable. So, well, I hope it's something you guys have you get a chance to do. There's all sorts of how-tos online, and I'm always available as well. If you folks are ever interested in doing that, we fly these things pretty often. And again, as far as hobbies go, $100 flight to 100,000 feet, that's not bad. Yeah, I usually end up spending more getting the kids ice cream after recovery, because we got to stop at the Dairy Queen. That's our ritual. Oh, yeah. Is that a ritual now? Oh, okay. We got to stop at the restaurant, take your laptop in to the McDonald's or Dairy, whatever, and open up the camera and pull the chip out and see what kind of cool stuff you see. You know, that's kind of cool sitting at a table, because then you've got all of everybody else coming by going, what's that? You know, as you're running a laptop there at a table eating a burger and watching images, live images that you're the first humans to see, you know, of the edge of space, and where did it explode? You know, where did the balloon pop? And oh, wow, we went by this and we flew over this thing. And yeah, it's kind of fun. Again, it's like 5 hobbies all in one. You got the geocaching or the storm chasing aspects, all these other little hobbies put together. So
You left out fox hunting.
and fox hunting. Yeah. For the non-hams, that's trying to track something down by using a radio signal. So yeah, I've driving around with a funny looking antenna sticking out the car window it always gets interesting looks. They think you're with the FBI or something. I need to get a nondescript van, drive around with big antennas sticking out the windows. And
No, you need a mystery machine. That's what you need. But yeah, how many UFO reports you figure you've been responsible for?
oh, right after the eclipse when was that? It was 2017, right?
Right.
Right after that eclipse, the only thing on Twitter and YouTube was UFO sightings, because again, you saw how many we had up. Everybody was outside looking up, right?
Yeah.
A lot of these balloons were backlit by the sun, or glowing by the sun during totality. So because they were off to one side or another. So there were something like 400 or 500 UFO reports across the country on like YouTube and Twitter. Imagine how many just folks in the countryside saw our balloons up that day and were like, we're being invaded. I've always wanted to send up like a fake UFO, you know, just kind of, but yeah, every flight I seem to hear from somebody on Twitter that says, what was that? But you'd be surprised with 92 flying every day that there wouldn't be more, but yeah, it's always the weather one, or swamp gas, right?
Yeah. All right. Any other questions? Well, this was a lot of fun, Paul. Thank you very much for speaking.
Absolutely.
And we'll let you know when we launch, okay?
All right. Take
Thank you,
care,
Paul.
everyone.
Thank you.
73.
73s.
So now we're going to do the boring part, right? Let's see. Let me get back to PowerPoint here is somewhere. So this is the not fun part. Slideshow from beginning. Here we go. See if this works. Yay! All right. Thanks for coming.
Bye-bye.
Come back. All right, so that was fun. You know,
Really cool. How did you find out about?
so this is somebody that Tom met at the Green Bank Star Party. And so star parties, you meet all kinds of fun stuff. And the fun thing about hobby astronomy is it tends to intersect with a lot of other hobbies. Like there are a lot of hobby astronomers that do radio, that are ham people, that, you know, that a lot of the younger folks. You go talk to Dr. Billy out at Denny. He loves anything Raspberry Pi. He's up for. So there's a lot, and that allows for, they're so cheap. I mean, when we were young, there were some, I can remember seeing a hobby computer that was made when I was like 17. And it was, and you had to put in the ones and zeros by yourself. It's just not as much fun. Right? So it's just really cool that and it's a fun community, right? All right, so we're here, we're called to order, yay. Hopefully some people do go and actually read the minutes when they come out in the newsletter. If you ever find any glaring errors, please let us know and we'll fix that. I'm going to tell you that we have a little bit of money in the bank since I'm also the treasurer. Really, nothing's happened in this last month, so our bank balance is still 96,7304. We've got 350.35 in PayPal, We're liked by about 2,000 people on Facebook and 318 current followers on X. Okay. I actually have 3 quotes for solar glasses now. And I guess
For what?
for glasses for the next eclipse.
Oh.
And my personal inclination is with the best price I got is 45 cents a piece. And I can get 5,000. And that sounds like a lot, but honestly, I was working up at Bowling Green for 2017 and we evaporated 100,000 pair. It's not hard to do. By the end of the time, we were selling viewers that said, visit Bowling Green to White House, Tennessee. Because they had an event and they didn't think they had enough. So yeah, it's amazing. So anyway, I want to have a stock on hand so that, again, if we buy them for 45 cents, we can sell them for $2. We can sell them for $1. I think the last time the deal was that everybody that was a member got 2 pair for free that year. So we might run something like that again. That's always an incentive to join the club, right? But since both of them will be partial here in Nashville, you'll need glasses the whole time. And talk to your friends and neighbors about that because I got an email from the Discovery Center down Murfreesboro way. They're having a Steam Palooza Day, October 14th. And I said, did you know that there is a solar eclipse going on that day? And she said, no, I didn't know we could see it from here. I said, we don't see the annular, but it will be 50% covered here. So maybe you should get some glasses for people attending this event. Then she wanted to know if I knew where there were free ones. And I go, oh, they're never a cost. You will make money on them. I don't care. Just go get some. Find the hardware store that wants their logo on them, get them to sponsor them, whatever. Schools do the same thing. They're all worried about how much money it will cost. It costs you no money. Get the PTSA to fund the initial cost, sell them, you'll make them in. Anyway, I don't sell anything normally. I'm not a salesperson. I cannot make money doing that. But these, I wouldn't have believed it so much except that I saw them evaporate and it was fun.
Calm down, Theo. Take a breath.
Yeah, take a breath. So BSAS has some loaner equipment. I just got back one of our Dobbs. So there's stuff available for loan. Yeah, and it should leave my hallway because it's fun to trip over astronomy equipment, but not really. So anyway, it's a nice way to try things out before you buy them. We've got a varied number of things, and I think we continuously accrete telescopes because people pull them out. This is Grandpa's telescope. Nobody's used it in 20 years. We'll give it to BSAS. So anyway, we end up getting stuff. Sometimes it's good stuff. Sometimes it's old stuff, but we got it. We have a nice website. And again, when you find errors like I've messed up on times or whatever, please let us know. Somebody please look at it because I mistype as often as anybody else. One of the cool things about it is the clear sky clock at the bottom.
And again, explain which color is clear.
So, okay, blue is clear,
Blue.
white is cloudy. Down here with the humidity, red is bad. That's really high humidity. Green is much better. And they do now have a smoke map too, which occasionally is not blue. We had July, there was a lot of smoke. So yeah, today I thought it lied for most of the day, although apparently Franklin and southern Nashville, it was pretty clear. Up our way, we were perpetually clouded out the entire day today. So like I said, personal cloud.
Hey, Theo,
Yes.
this is Chuck. Can you
Hey, Chuck.
share your presentation? We're seeing the video
Oh, you're seeing the
of
video
you.
of me. Oh,
Yeah.
that's not good. All right. How do I? Oh, that's because I'm in. All right. Thank you for, so see, that's a good example. Thank you for share screen. I'm going to have to share. Let me haul this. Move this over here. restart this slideshow.
Thanks, Chuck. I thought you just couldn't show it.
No, that's just, so let's see, didn't minimize that. Let me slideshow from current slide. And then need to booger out of, hang on a second. I don't do this all the time, so it's, like I said, you need to talk to me and say, hey, where is my Zoom window here? Because what I need to do is share it, yeah. Where did that go? Well, wait, here it is.
Well, I'm seeing the same thing on Zoom and YouTube.
Well, it should, hopefully. Okay, let's try this. Blink. Blink. Oh, shush up, what's that? Okay, is that any better?
Yep.
I'll get some of this other stuff moved back over to its.
Yeah, that's good. Thanks.
There we go. All right, now you know what I'm talking about. And get my presenter view dragged back up here. Wow, the computer says, I am working so hard. Okay. And yeah, we have the hatch print. Can I get rid of, probably can, but you guys see the sidebar with people, or is that just personal to me?
Right now, the screen just grayed out for us.
Really?
We just see a little something down in the lower part of the screen. Otherwise, it's all gray. Not the end of the world, deal. Oh, here it comes again. I guess it's just slow. It's refreshing slow.
Oh, it might be slow because I'm on the wireless connection here at the Girl Scout
Yeah.
office. Is it coming in better?
It's taking time to refresh. I wouldn't worry about it, deal.
Okay. Let's see, is that still on?
You probably have to put another thin mint in the slot for it to work right.
Yeah, it's probably trying to do way too much all at the same happy time. So yeah, we have a website, we have a Facebook page, and thank you, Chip, for putting our events and stuff on there because I get busy. I'm just not a social media person. That's just not, I don't take a lot of time out of the day to do that. So it's always nice when folks do. We do have Twitter. I guess we should change that to X, but whatever. And I try to repost things that are just interesting to me, you know, so if somebody comes out with a cool astronomy picture or some cool science comes out, I'm going to hit that and then we try to use this day of a star party if it's going to rain or we're going to cancel Twitter, Facebook, the webpage, we try and put that out. All right. Instagram, thank you, Steve, for doing that. Because that's another thing that I don't do Instagram at all. And we have a Google group for members, which is a great place. And it was well used this last week when people said, who's going out to the Natchez Trace? And people chimed in and there was a nice group out there. So that's a great way to use that, is to, you know, communicate between members and tell each other what you're doing. So let's do some more of that.
That was one of the best star parties. Really good.
Yeah.
Fantastic viewing, good astrophotography. We had people there. The first meteor shower was
Yeah.
the best I've ever seen in my life. What was this? Yeah.
So
And
we have members only parties. They're kind of private where we just take our gear out and play with it rather than having a line of public. And so we have a permit from the Natchez Trace for 2 sites that we kind of alternate between. to go out there and use those pull-offs at night, because otherwise the Natchez Trace is closed at night. Kind of. I mean, they can't really forbid people from driving on the road much, but they don't want you there because there's nowhere to be. You know, there is one campground in Tennessee, but unless you have a reservation, you're not there. So the only caveat about both those places is they have no facilities. So just be warned. We have trees, that's all we got.
A question on that, this is a number for it. What is the possibility of trying to arrange some sort of security for those events? It really wasn't an issue, but there were a couple people concerned about it. Has that ever been thought about?
That's one reason why we have to have a permit, and sometimes the rangers during their, because they do kind of drive around at night, they'll stop in and make sure that, but that's why I don't want anybody out there by themselves either.
Well, I just wonder, what would possibility do you have in rent a security guard for anything?
I don't know.
Have business pay for it?
Yeah, that'd be something we could look at. I don't know how the Trace would feel about that, but that's something we have to ask them.
Just for discussion, but.
Yeah, but yeah, it's a lonely place. Having said that, Ron Ladd, Ron, are you on? Yes.
Yes, I am.
Has said that if we want to, he lives like right off the Trace, and he's cheerful to have people over.
Yeah, I was going to bring that up. If you're thinking about coming down to Water Valley, you can come to my place, where I have a shed that has a bathroom and has power, and also heat and a refrigerator. So it could be a much nicer experience than you would have over at the Trace, and it's essentially the same sky. I live about 2 miles as the crow flies from the Water Valley overlook.
So that would be another excellent use of the Google group.
Ron's site gets a 10.
Yeah.
I was gonna bring that up about the September private star party, but I'm not sure how that timing relates to Pickett. And of course, Pickett skies would be better if people wanted to go over there.
Yep. Pickett is hosting a dark sky celebration weekend. And I think that's the same weekend. I could be wrong. But that is on my calendar. Whoops, wrong one.
15th to 17th, right, Dale?
Yep, 15th to the 17th. So that's the Friday night, Saturday night, and then leave on Sunday. That's at the group camp at Pickett, and they have bunkhouses that are climate controlled. They also have bathrooms that are climate controlled, and they have a really stinking nice field and a big meeting room / kitchen. And they usually do a good job of getting some food together for it. So that's an option too. I'm hoping to get up there. All right. So lots of cool things we can do, and members should, chat amongst yourselves and we'll get some things going. So Night Sky Network is where we keep track of the membership. So that's where you can go. And if you move or something like that, please change your address, because we use that to send out the quarterly Reflector magazine that comes from the Astronomical League. So
Night Sky Network is also where all the private star parties.
yes, that's where the calendar is for the private star parties. And
they're not on the website, or they're not on Facebook or anywhere online, just here.
so, and the other cool thing is Chip's been sending out invites like through their event notices, and then you can actually sign up and say, yes, I will be there, which makes everybody much less anxious that we're going to have a few people show up. And it lets us track how many people go. And that's the thing, that if we ever got to the point where we were like applying for grants or something, that's what they want to know. How many volunteer hours do you do? And if you want to keep track of your volunteer hours, when you get to 50 hours, you can get an outreach award from the Astronomical League. So that's a cool thing too. I'm working on my Master Outreach Award, which I would have already gotten except for stupid COVID, but all right. So that's a very useful. Also, Night Sky Network has a lot of cool, they've got a whole section of educational resources. and little activities that you can do. And the cool thing with the activities is they not only tell you how to do it and what you need, to have videos of people doing it. So it's incredibly useful, especially for teachers or if you have friends that are teachers. I'm going to be making a comment at the end of September at a library. And that's just a ton of fun. I'm not cool enough to have liquid nitrogen, but I will have CO2.
So when is that magazine mailed out?
Quarterly, and I just sent in a new mailing list here in June. So if you haven't gotten one yet, you should get one maybe in September. It comes out like 4 times a year. Just a skinny little thing.
Is it the
Digital
same
or
thing that's
paper?
in the email? Because we get an email.
No, that's the Eclipse.
Oh,
That's the
yes,
Eclipse,
okay.
yeah. That's from us. The other is from like the larger umbrella organization called the Astronomical League. And yeah, there's some cool stuff that was on Night Sky Network. And they also have what's up, you know, what you should be looking for. So there's a lot of good resources there. We had a public star party at Bowie Park, which was mostly a star party for us because I think there were as many of us as there were public. And then, yeah, there was the private star party. Upcoming this Saturday at Warner Park at the special event or model airplane field. And hopefully people go. I'm going to be AWOL, so I will not be there. I have
to be out by 10:30.
You don't have, that's when we tell the public to leave, because otherwise people would stay on. Now for that one, I'm going to say, and I'm going to put out a mail on the groups about this. You do have to be there if you are coming with a telescope and you don't want to have to schlep it a long way. You have to be there early because there's a gate onto the tarmac. We drive onto it, you park and set up, but that gate gets shut before the public comes in, because otherwise they would drive onto the field. And we don't want them to do that. So
What time is that about?
So the star party starts at 8:30. I would try to be there no later than 7:45, something like that.
Are we allowed to drive on the tarmac? I thought we weren't allowed to drive.
No, we are allowed to drive
We
on
are.
the tarmac. Yep. There's been some words occasionally from the airplane flyers. We don't hurt their tarmac. And that site was built with BAS in mind as well as the model airplane field. That's really ancient history, but you can have a fun conversation sometime with one of the park people that was there at the time. So
Plus they have bathrooms.
plus they have bathrooms, yeah. All right, and then another private star party. If you're not going to Pickett, you can either go to Water Valley, or you guys can call Ron Lab and say, if you're not at Pickett, maybe we can be at his house. So, and then our next member meeting, I'm going to try to bend somebody's arm about that. The Mill Ridge Park in September. I know Tony has strong opinions about Mill Ridge. They actually, I emailed somebody about that, and I have not, twice now, I have not gotten a response. So I'm going to do some phone calling. The park itself has been under construction for a long time. It had a opening here like last weekend. Or is it this week? Anyway, they're opening the actual park. The people who've been asking us to do star parties is the Friends of Mill Ridge rather than the park itself. So I need to find somebody, because we're not on their calendar. And so I just want to know what's up and
Where is that?
it's kind of near Cane Ridge High School in Antioch.
Yeah.
No, it's not. It's on the opposite side of the interstate from Cane Ridge High School.
Okay.
Is it 12, 12944 Old Hickory Boulevard?
It's
Something like that, yeah.
It's nestled between the TA truck stop on I-24 and Old Hickory Boulevard and the Bridgestone Tire Plant.
But anyway, I'd like to go out there because I've never been there and I don't,
K4BW, looking for check-ins. Anybody else out there yet?
and I don't feel real comfortable telling people how to get to someplace I've not actually gone to. So anyway. I don't have a lot of reason to drive to Antioch either. So if anybody does, let me know. That's not a normal place. So we have some fun stuff coming up. Lunar occultation of Antares. Do we get to see that here? I haven't looked that up. It's fun to watch the moon occult a star just because that really brings home how fast the moon is moving in the sky during the evening. Not just the usual movement with the rotation, but that it's actually moving to the east as it goes around the Earth. So you can watch it blot out a star and then, sometime later the star comes back. So that's a little fun.
Yeah, Theo, I checked that. I think it starts around 10:36 in the evening on the 24th.
Okay. So low in the south. That'll be fun. Saturn is always fun to see. And then super blue moon, yada, yada, yada. It's a pretty moon. The moon is always pretty. Neptune in opposition. Yeah, Neptune. Every now and then my husband brings his great big gob out, and that's when you can see Neptune. Little tiny blue circle. Mercury, and another full moon. And that's the end of it there. So anybody have any questions, comments? Is there any other?
Can you,
Go back.
Back up on the screen, please. Thanks.
And then, of course, the next new moon after this is the annular eclipse. And I'm going to be in New Mexico for that. So.
Why couldn't be 2 hours west of here?
That's for the total eclipse in April. Yeah, but this one, the moon is not quite far enough. It cannot, or it's too far. It can't cover the sun. So we'll be left with a ring all the way around. And I've never actually seen one of those. So I got to add that checkbox. So.
I'm from Roswell, and I was thinking of going, in October for it, but I realized probably like in the last 5 years, I've been there twice at the end of September and October. And it's right when October hits, it gets really just overcast gray, the weather really turns. So I was talking to my mom like last week, and I was like, I really wanted to go, but I know the weather's probably not gonna be that great. And yeah, I should just go to visit you guys, but I kind of don't think I'm gonna see anything. So just keep that in mind.
I'm gonna hope it's better.
That's the part of the state, but.
We stayed at Bottomless Lake State Park in April. And that's where I'm booked for this.
Okay.
So we'll hope for better. There's a group in New Mexico that has the Enchanted Skies Star Party. And it was late in October, the year we went out. And it was clear, but it was cold.
Yeah, it gets freezing.
We were kind of expecting 32, freezing, and it was 18 the one night. And we had rented the camper, and we weren't clear on how cold we could go before the, water tanks froze and things. So it was okay, but it was colder than, than you really want to be out. But the sky was pretty.
Yeah.
And for that, we were up a little bit north of there, not too far out of Socorro. When you go from Socorro, you drop down a little bit, and you head towards the very large array. And there's a little town there called Magdalena. And you're at 7,000 feet, and it's flat. And the skies were really nice. I was one night, I went out of the trailer because I was having the telescope take some pictures, and I get all this extra layers on to go out, and you're complaining. And then I stepped outside, and it was early morning, and the winter sky was already up. And I just stood there and said, well, dang, that's stupid pretty.
Yeah, you see everything.
Yeah. The winter sky, I mean, the summer sky has the Milky Way, but for my money, the winter sky's bright stars just blow that away. I love the bright stars of winter. but
There is a lot open in Mexico.
yeah. So, a whole lot of area that has no cell phone service. So,
Really? Oh, yeah.
oh, man.
Yeah, no cell phone service, you're not gonna be able to use a GPS to go
Yeah.
anywhere, you know, gotta get out the map like you did back when we were pirates and.
The Magdalena, if you're ever there, you have to stop. There's a gentleman there that runs, he's got the old high school gym, and it's called the Astronomical Lyceum. He has telescopes, like it's just amazing collection of old telescopes, magazines, books. He had E.E. Barnard's Bible, his personal Bible. And also a first edition of his, collected plates of Milky Way pictures, which he found somewhere that somebody that didn't know what they were worth and got it. Anyway. And you can visit the very large array, which is also cool. Anyway, we're gonna try to do that after the eclipse. That's when they're holding the Enchanted Skies Star Party this year. It's gonna be in Pie Town, which, yes, you can buy pies there. Seriously what they do. And that's on the US 60 that goes. So we might head up there and maybe look at property if there's anything interesting for sale. Oh, man. Anyway, thank you guys for coming, and we'll call that a night so that the online isn't so long. So thank you, everybody, for coming. Hope to see a lot of people. I hope a lot of you see each other at the Star Party on Saturday night. And otherwise, we'll be chatting on the group.
Thank you, Theo.
Thank you.
Thank you. Thank
Good
you.
night.
All right. And how do I?
Access to Google Group. It has to report in that.
Um,
You go to Google.
shoot.